If I try to factor it as is, I'm going to have an issue. So the first thing I'm going to do is I'm going to take out a GCF. I'm going to divide everything by 3. I'm going to take a 3 out. Now I'm at the same point. I have letters that aren't going to help me if I factor. So it's time to do a little bit of rearranging. So I'm going to move this A to the front and move this -2 to the back. Just because I have to find a way to factor this. So now looking at this, I could say, hey, I could take an A out of these first two. Out of the second two, I know I could take out a -2. And look at that. My parentheses are the same. So therefore, I can factor this. So I can factor out that B plus 1, and what's left over is the A minus 2. The biggest mistake people are going to make is they're going to forget to continue to carry the 3 down. So do be cautious. There is no solving that can be done here. So again, you just move on. All right. This next problem is particularly ugly, and you'll notice that it resembles number 14, at least initially. Okay, I have x squared minus 10x plus 25 minus y squared. I have 2 different variables. I have 4 terms, so you might initially try to factor by grouping. However, when you do that, you're going to notice your parentheses don't look the same. Therefore, you cannot factor by grouping. So, when you cannot factor by grouping, try to factor the first 3 and see what you get. In this case, I recognize this as one of my simple forms. Okay? Numbers that multiply together to give me 25, add together to give me -10, are -5 and -5. Because they're the same, I can write it as x minus 5 squared. So now I have something squared minus something squared. I don't care what those somethings are. They're squares. Because of that, I can take the square root, which means this is the difference of 2 squares. So, because of that, I already know how to write it. Okay, first term plus the second term, first term minus the second term. Okay, and then I'm going to clean it up because I don't like having multiple grouping symbols when I'm doing this. So my final answer looks just like that. I just dropped the internal parentheses and I got rid of the brackets and made them parentheses because that's what we are accustomed to seeing. Ultimately, it does not matter. Okay, one more example. Okay. Here we go. Similar situation. Okay, x squared plus 4x plus 4. Again, you could try to factor by grouping, but odds are you're not going to be successful. So I'm going to try to factor the first 3 terms again. Numbers that multiply together to give me 4, add together to give me 4, are 2 and 2. So, and it's also positive 2 and positive 2. So, because they're the same, I can write it as squared. I could take the square root of 81, so that is the difference of 2 squares again. Okay, it's very, very important that we're able to recognize that. So then, I take the square root of the first. Okay, square root of something squared is just what's already there, so it's just x plus 2. Square root of 81 is 9. Square root of y squared is y. So I have the group minus the second, and the group plus the second. So that pattern still holds. And then I dropped the interior groups. So there's a quick rundown of some advanced factoring techniques. We will talk about these tomorrow. So have a great day and enjoy your practice.